Okay, so we are moving on to our second day of circles. Let's take a minute and do the do now. I want you to pause the video right now, do the do now, and then when you're ready, play it again. So it says, if the length of a chord AB is 24 centimeters and the diameter is 26 centimeters, what is the distance from the chord to the center of the circle? So I'm going to set up this diagram. So obviously we have a chord and then we have a different chord being talked about that's a diameter. I'm only going to draw in chord AB. So here's my chord AB. Now they're telling us the diameter is 26. I'm actually not going to draw on that diameter. Why is this information valuable if I'm not going to draw on the diameter? Because we know a radius is half the diameter. So if the diameter is 26, the radius has to be 26 divided by 2, which is 13. So we're going to keep that in our heads because that's going to be more helpful information. It says, what is the distance from the chord to the center of the circle? Now remember, the distance from the center to a chord is the length of its perpendicular. So we're trying to find that segment right there. Now we know the radius is 13, and we know A to B is 24 centimeters. We also know that a perpendicular from the center will bisect that 24 and make it 12 and 12. The last thing I'm going to do is I'm going to draw in this radius. I'll draw it in from O to A. You could have drawn it in from O to B. We know that radius is 13. Remember, radius is from the center to the rim, so that is absolutely radius. And now we want to find the length of the perpendicular. Well, using this right triangle, we know we have a triple, something 12, 13. What is it? 5, 12, 13. So the length of from the distance from the center to the chord is 5 centimeters. Okay, let's go through some theorems. It says if two chords are equidistant, from the center of the circle, then they are congruent. What does this mean? If two chords are equidistant from the center of the circle. So that means if two chords, both coming from the center, are the same distance from the center of the circle. That's what equidistant means, an equal distance or the same distance. Well, how do you measure the distance from a center to the chord? Isn't it the length of its perpendicular? So they're saying if this perpendicular is congruent, then this perpendicular is congruent. So that's an equal distance. If the two perpendiculars are congruent, then they're saying then the actual chords are going to be congruent. So the chords that they intersect will be congruent. So if the perpendiculars are congruent, then the chords are congruent. Now, the reverse of this is also true. It says if two chords of a circle are congruent, then they are equidistant from the center. What does this mean? This is telling us, if we start out by telling us that the two chords, so for here it's A, B, and C to A, if they're telling us if these two chords are congruent, that means they're the same length, then they're both the same distance from the center. Well, what does that mean? The distance from the center to the chord is represented by a perpendicular. So they're saying if the chords are congruent, then the perpendicular segments also have to be congruent. Okay, so if the perpendiculars are congruent, then the chords are congruent. If the chords are congruent, then the perpendiculars will be congruent. Let's do some problems. So here we have given circle O, so we know the center of our circle is O. Now we're being told that a segment AB, which is a chord, is congruent to segment CD, which is also a chord. Now if the chords are congruent, I guess I drew that chord a little short. There we go, there we go. So the two chords are congruent. Now we know if the chords are congruent, aren't the perpendiculars also congruent? Now they're telling us that OP is represented by 12x minus 5 And we're being told that OQ is 4x plus 19. We want to find OP. Well, in order to find OP, we need to solve for x. How are we going to solve for x? Well, we know these perpendiculars are congruent. That means I can set their expressions equal to each other. 12x minus 5 is going to be equal to 4x plus 19. We're going to subtract 4x on both sides. And we are going to have 8x minus 5 is equal to 19. We can solve this. I'm going to add 5 on both sides. So 8x is equal to 24, and x will equal 3. Now be careful, I wasn't asking for x. What was I asking for? We were asking for the length of OP. Well, we know OP is represented by 12x minus 5. So we're going to say 12 times 3 minus 5. 36 minus 5. And we are going to simplify it all the way down to 31 units long. Okay, moving on to the next one. Here we have circle D. That means the center of our circle is D. Then we're being told that DF is congruent to ED. So this time I'm telling you the perpendiculars are congruent. Well, we know if the perpendiculars are congruent, then the chords are also congruent. Now, what else are we being told? We are being told that A to B is 2x plus 7, and A to C is 14x minus 53. We want to find AB. In order to find AB, we need to solve for x. Well, we know these two chords A, B, and CA are congruent, so I can set their expressions equal to each other. 2x plus 7 is equal to 14x minus 53. Let's subtract the 2x on both sides. So we're going to have 7 is equal to 12x minus 53. Let's add that 53 on both sides. We are going to get 60 is equal to 12x. Divide by 12. We will get x is equal to 5. So what were we trying to find? Do we want to find the length of AB? Well, we know AB is represented by 2x plus 7. So let's plug that right in. 2 times 5 plus 7, which is 10 plus 7. So we know the length of AB is 17 units long. Okay, moving on to the next one. So they're telling us circle E, so we know E is the center of the circle. We are being told that A to B, so this whole segment, is 5x plus 10. We're also being told that C to D is 10x minus 10. We're being told that the radius is 17, so we'll keep that in our heads in case we need to use it. And that GE is congruent to EF. Well, if GE is congruent to EF, that means our perpendiculars are congruent. If our perpendiculars are congruent, then our chords are congruent. Now they want us to find EF. The thing is that there's no expression on EF to be able to solve for a variable and substitute back in. So we're going to have to take this a little bit further than we've been doing. Let's start off with what we know. We know the chords have to be congruent, so let's set them equal to each other and go from there. So we have 5x plus 10 is equal to 10x minus 10. We're going to subtract the 5x on both sides. So we're going to have 10 is equal to 5x minus 10. Add 10 on both sides. We're going to have 20 is equal to 5x. So x will equal 4. Now what I'm going to do is I'm going to take this 4 and I'm going to substitute it into the chords. So we have 5 times 4 is 20 plus 10 is 30. So this chord is 30, which means this chord is 30. Now remember, what is the perpendicular from the center due to a chord? It bisects it. So if the whole chord is 30, each part of it is 15, which means on this side, each part of it is also 15. Okay, let's go back. What are we asking for? We're asking for EF. Still not there yet. We have no way of figuring out what EF is. Well, let's go back. Was there any information that we were given that we haven't used yet? Sure. We were told that the radius is 17. So guess what I'm going to do? I'm going to go from my center and I'm going to draw in a radius that's 17 units long. And what I hope you realize right now is that we've just created a right triangle. Not only is it a right triangle, it is actually a triple, something 15, 17. 8, 15, 17. So we wanted to find EF. Well, EF we just found to be 8 units long. Okay, next one. We have circle O. We are told that P to B is represented by 3x minus 17. We are told C to D, now be careful, that's this whole segment right here, is 15 minus x. And then we were told that OQ is equal to OP, so OQ, so the perpendiculars are congruent, and they both equal 3. So that means they're each 3 units long. All right, we want to find AB. So in order to find AB, I need to solve for x. Let me tell you what's wrong. The most common mistake here would be 15 minus x is equal to 3x minus 17. That is a big no-no. We don't want to do that. Why do we not want to do that? Well, CD is the whole chord, where 3x minus 17 is just half the chord. But we know these two segments have to be congruent, so this is another 3x minus 17. So what is the right equation? The right equation should be 15 minus x is equal to 3x minus 17 plus another 3x minus 17. Let's combine our like terms on the same side. So 3x plus 3x is 6x. Negative 17 plus negative 17 is a negative 34. Let's add 34 to both sides. So we're going to get 49 minus x is equal to 6x. Let's add that 6x over. I'm sorry, let's add the positive, not add the 6x, let's add a positive x over. So we're going to get 49 is equal to 7x. So x will equal 7. Now that we know x is equal to 7, now we can figure out the length of A to B. Well, we know AB is the same as CD. So I'm going to plug in for CD. We have 15 minus 7, which is 8. So if CD is 8, that means A to B is also 8. Now we want to find a radius. So I'm going to do the same thing I did last time. I'm going to go to the center of my circle. I'm going to draw on a radius. I'm going to focus in on the right triangle. Now this time I only have one side label. I only have the altitude labeled as 3. Well, we know C to D is 8, and we know the perpendicular will split it in half. So we'll get 4 and 4. So this actually ends up being a triple, a 3, 4, 5. So the radius of the circle is 5 units long. Alrighty, let's turn the page. So here we have circle O. We want to find the radius and we want to find the diameter. Okay, well, what are we being told here? We are being told that chord AB is congruent to CD because they both have the same amount of tick marks. So if AB is 48, then CD is also 48. We can also make another conclusion. If the chords are congruent, then the perpendiculars have to be congruent. So let's go ahead and solve for x. So 2x plus 1 is equal to x plus 4. I'm going to subtract the x on both sides. And we're going to have x plus 1 is equal to 4. Subtract the 1 on both sides. And we will have x is equal to 3. Now I'm going to substitute in my x. We have 2 times 3 plus 1, so 2 times 3 is 6 plus 1 is 7, so this is 7 and this is 7. I also know the whole chord is 48, but the perpendicular from the center is going to bisect it. So this will split into 24 and 24. Now we want to find the radius. So what am I going to do? I'm going to draw in a radius. Ooh, I should draw it probably from the center. Be a lot better there. There we go. I drew in my radius from the center. And I'm going to focus on that triangle. And guess what? Once again, we end up having a triple. It's 7, 24, 25. So the radius of our circle is 25. Now for the diameter, we have to remember a diameter is equal to 2 times the radius. So if the radius is 25, the diameter is 2 times 25, which is 50. All right, moving on to number 6. We have that FD is congruent to FE, and we have circle F, so we know the center of our circle is F. Now we know if the perpendiculars are congruent, then the chords have to be congruent. Now this time I'm not asking for segment lengths. This time I'm asking for angle measurements. So I want us to think way back when we were working with triangles. And I want you to look at this big triangle right now, A, B, C. We know angle C is 60. And we just concluded that AC is congruent to BC. If we have a triangle with the legs congruent, don't we also have the base angles congruent? So I know angle A and angle B have to be congruent. How am I going to find their measure? Well, we know a whole triangle, all the interior angles of a triangle have to add up to 180. So I'm going to take my 180. I'm going to subtract 60. We'll get 120. Then I'm going to take that 120 and divide it by the 2 angles. So each angle has to be 60 degrees. So angle A is 60 and angle B is 60. Number 7, so we have circle P. We have PQ is congruent to PR, so if the perpendiculars are congruent, then we know the chords have to be congruent. So A, B, and CD have to be congruent. We have AB is represented by x squared plus 11x. And now be very careful how you label this. DR is equal to 2x plus 30. So just d to r. Well, if d to r is 2x plus 30, that means CR is also 2x plus 30. Now we want to find CD. Well, in order to find CD, we need to first solve for x. Now we know AB, segment AB has to be congruent to segment CD. So CD is not 2x plus 30. CD is going to be 2x plus 2x, so 4x, and then 30 plus 30 is 60. So our equation is going to be x squared plus 11x is equal to 4x plus 60. Now we have to solve for x. How are we going to solve for x? We actually have to factor. How do we know we have to factor? You know you have to factor because you have an x squared term. So what am I going to do? I'm going to go ahead, I'm going to subtract 4x on both sides. I need to set this whole thing equal to 0, so we're going to have x squared plus 7x equals 60. I'm still not done. In order to factor, we need it to equal 0, so now I'm going to subtract that 60. So we're going to have x squared plus 7x minus 60 is equal to 0. Now we are able to factor. So remember, I need two numbers that multiply to a negative 60 and the same two numbers that add to a positive 7. So two numbers that multiply to a negative 60 but add to a positive 7. What are my numbers? It's going to be x plus 12 and x minus 5. We're going to take each one of these parentheses and set it equal to 0. So we have x plus 12 is equal to 0, and x minus 5 is equal to 0. X will equal negative 12, and x will equal 5. Now my question for you is, are we allowed to have a negative x value? Are we allowed to have a negative x value? And your answer should be, absolutely we are allowed to have a negative x value. What we're not allowed to have is a negative length. And no matter what we plug in, whether it be negative 12 or positive 5, we will not get a negative length. So we are actually going to have two answers. So CD, when x is equal to 5, is going to be 4 times 5 plus 60, which is 80 units long. And CD, when x is equal to negative 12, is going to be 4 times negative 12 plus 60, which is a negative 48 plus 60, and that gives us a positive 12. So we have two answers for CD. Okay, let's turn the page on our last page now. These are independents. What I'm going to do is I'm going to give you these answers, and if you want, you can try them all by yourself. So OP will be 9. CD is 8. The radius is 5, and the diameter is 10. All right, guys, so your assignment for today was only to watch and take notes and understand the video. There is no homework assigned for today, just to understand this video. So have a great day, and we will talk again tomorrow. Bye-bye.